18. Okay, we are in our notes on page 18. The lesson is 6.4. The objective is to solve compound inequalities. As I mentioned a minute ago, this lesson can be confusing, so you need to make sure you're staying with me. If I ask a question or ask if you're okay, please be honest with me today. Make sure you get this. All right, so compound inequality, just a basic definition before we get into the details here, consists of two separate inequalities joined by the word and or by the word or. Or at the very top of the page, you're writing down the definition for compound inequality, page 18. Right here. So compound inequality, there's two of them. There's an and compound inequality, and there's an or compound inequality. If it's an and compound inequality, it's connected in the middle because x has to be between two numbers. If it's an or compound inequality, x is either going this way or x is going this way. X is going in one direction or the other. So we're going to talk about two compound inequalities today. One of them is and, one of them is or. We're going to start off this lesson very basic, just how to graph them. We're then going to move on to verbal expressions. How do you translate them to a compound inequality? And then lastly, you're going to learn how to solve and or compound inequalities. Yes, you'll learn the graphs as well. Okay, so just a little overview of today. We'll see how far we get. I'm going to skip around, and as long as you're doing okay, we're going to skip some of the graphs just because of time, so just make sure you're paying attention. Okay, first thing I need you to do is on the left-hand side of this chart, I need you to make 4 tick marks on this number line, and this number line that are just like mine. After you make 4 tick marks on each number line, I need you to number them from -2 up to 1. I need to make 4 tick marks, number them from -2 to 1. Okay, so here's what we're going to do. We're going to graph these as a review. Down here too. 4 tick marks, same numbers. We're going to practice graphing these back from 6.1 and 6.2 like we did, so that you're okay when we graph them as compound inequalities. So let's start here, Alec. If x is greater than -2, what kind of circle do we need to have above -2? Oh yeah, that's right. Okay, think about it. If x is, Buzz, turn around. If x is greater than something, can it be equal to that number, Buzz? No. So you should have an open circle because it has to be greater than -2. Okay, you okay now? Probably. X is greater than -2. You have an open circle above -2, arrow going to the right. TJ, if x is less than or equal to 1, what kind of circle should we have above 1? Good. Filled in circle because x is less than or equal to 1. So it's filled in, arrow going to the left. Does everyone remember when you should have an open circle and when you should have a closed circle? You could do this. This is left. If you make L's with both your hands, whichever one makes a normal L, that's your left hand. That's left. Okay. Questions or comments on this? Okay, let's now take these and transfer it down here. So towards the bottom, let's start with this top one. This is an example of an and compound inequality, which is what it says up here. And compound inequality is the intersection of the graphs of the inequalities. So when you have the word and in between it, you know it's going to be and. That's one way to determine. I want you to take, see how it says x greater than -2, but it says it backwards? We need to use symmetric poi and flip it around so that x is on the left-hand side, not the right. So let's do that. This says, and we're going to flip it around, x greater than -2. So make sure your x is always on the left-hand side. That's one thing you need to keep in mind. Now let's graph. X is greater than -2. We have an open circle above -2. Greater than means to the right. So I'm going to put a little arrow pointing to the right. Second one is, and x is less than or equal to 1. You should have a filled in circle above 1, just like we did here. TJ told us this one. Arrow going to the left. Now, it's an and compound inequality. You have the two arrows pointing towards each other. You need to connect them. It kind of looks like a dumbbell. Anytime it's an and compound inequality, it has to be an intersection. They have to connect in the middle. That means x is between these two numbers. It represents the intersection of the x values. An and compound inequality is always this way. Buzz. Yes, you may. Questions on how we did that? Okay, let's go to the second part here of this chart. I want you to do the same thing we did on the left. I need you to put 4 tick marks on each of the number lines and put numbers -2 to 1. While you're finishing that, so on the right-hand side, the top says the graph of a compound inequality with OR is the union of the graphs of the inequalities. So this one is a union, it's OR. X is going to be either greater than something or less than something. So your arrows on this one are going to be going in opposite directions. It's one or the other. Okay, so let's start with a basic review, and then we'll kind of mush them together towards the bottom here. Mitch, if x is greater than or equal to 0, what kind of circle should we have above 0? Good, filled in. Greater than or equal to means your arrow goes to the right. Okay, the second one is x is less than -1. Michael, what kind of circle should we have above -1? Good, open circle above -1, arrow goes to the left. We're going to mush these together so that they become an OR compound inequality. Here is an example of an OR compound inequality, which says x is less than -1, or it can be x is greater than or equal to 0. It's going to be one or the other. So let's graph these. X is less than -1. You should have an open circle above -1, arrow going to the left. Or x is greater than or equal to 0. You have a filled in circle above 0, arrow going to the right. So an OR compound inequality is always this way, an AND compound inequality is always this way. If your graph doesn't look like this and it's OR, then you did something wrong. If it's AND your graph doesn't look like this, you did something wrong. Has anyone seen this before? Some of you? Okay. Any questions on the introduction to this lesson? Okay, I'm going to skip around a little bit here. Let's start with letter A. Okay, so letter A, we have a compound inequality. Is this an AND or an OR compound inequality? Marian, how do you know that? Good, very good. That's all I need you to say. This is an AND compound inequality, and the reason is it doesn't say OR. You could also say it's AND because x is in the middle. If x is in the middle and it's either greater than or less than two other numbers, we're going to split it up. Very first thing I need you to do is look at the x in the middle. We're going to use symmetric poi, and we're going to flip this inequality around. So this is the part where if I could take this, pick it up, and flip it around, that's what we're doing. This really says x is greater than -2. Remember, we're using symmetric poi, and we're flipping it around. It's an AND compound inequality, so I need you to write the word AND in between it. The other part says x is less than 3. So x is greater than -2 and x is less than 3. Is everyone okay on how I split those up? Okay, let's go to our number line. Let's put -2, -1, 0, 1, 2, 3, and let's graph. So the first part, x is greater than -2. We should have an open circle above -2, arrow going to the right. So draw a little arrow going to the right. And then we have an open circle above 3, x is less than 3, arrow going to the left. The arrows are pointing towards each other just like they were on the previous example, so we are going to connect thumb, looks like a dumbbell, that represents an intersection. X is between -2 and 3, but it cannot be equal to those numbers. Okay, let's do the coordinate plane, then I have one more thing to say about that. On our coordinate plane, I'm going to scale it by ones, but I'm just going to write down where the -2 is and where the 3 is. Okay, Tessa, do you remember what kind of vertical line we should have going through -2 since it's greater than? Good. Dotted or dashed line going through -2. John, what kind of vertical line should we have going through 3? Good. Dotted or dashed line going through 3. Now, if we go back to, so x is greater than -2. Since x is greater than -2, we should shade to the right. So I'm going to put little lines there. Since x is less than 3, I'm going to put little lines here. We should also shade to the left. That means shade everything in the middle to represent it's an intersection. X is between those two numbers. Lauren. Can you, did you say? You could, but it's wrong. Do you know why? Okay, so when Lauren, you flipped it around like we did, right, Buzz? Okay, so x is greater than -2, so that means you're coloring or shading to the right, because x, oh, you could, but what you want to do initially is shade a little bit here, where the 3 is, shade a little bit here. Don't go beyond them, because x has to be between these two numbers. I split them up with you guys and girls to make it easier for you to graph them individually, but you really could graph it all at once, Lauren. Plot the -2, plot the 3, make your dotted lines, and then say, okay, it's an and compound inequality. X has to be between those two. Good question. Anyone else? Okay, one other thing I was going to say is kind of relating to what Lauren said. You do not have to split them up here, okay? But it probably will help you in regards to graphing. So I will keep splitting them up. If you want to graph them from this original problem, your call. Okay? Okay, let's go to letter B. Okay, letter B. Alec, what kind of compound inequality is this? Good. If you see the word or, it's an or compound inequality. So there's nothing you have to split up. We're going to graph this as is. So I'm going to put here, I'm going to count by 5s. So -5, 0, and 5. If x is greater than 5, Dan, what kind of circle should we have above 5? If x is greater than 5, not equal to, open. So if x is greater than 5, open circle, arrow going to the right. Trevor, if x is less than -7, should we have an open or closed circle? Good. Open circle above -7, arrow going to the left. Trevor, you with us? Are you writing notes? Okay. So there's our compound inequality of or. Arrows are going in both directions. X is either less than -7 or greater than 5. Okay, let's go to the coordinate plane. Let's put our -7 here, and let's put our 5 here. X is greater than 5. We have a dotted line going through 5. Since x is greater than 5, you should be shading or coloring to the right. X is less than -7. We have a dotted or dashed line going through -7. And you're shading to the left. So here's an example of or. You should be coloring on the outside of both of those vertical lines. What's wrong? Okay. So in or, it's always going to be like this, and your coordinate plane is going to be shaded on the outside. Okay, before I decide what we're doing next, give me a head nod. Are you following me? Are you finding this easy? Either this way or this way. Madison and Trevor, I just need to see a head nod. Are you following me? Are you finding this easy? Give me this or give me this. All right, thank you. Okay, I want you guys and girls to try letter G. So everyone flip over to letter G. I want to make sure, I want to make sure that everyone's okay with flipping these on your own. So on letter G, you okay? Okay. Figure out what kind of inequality it is. I want you to rewrite them just like we did and then graph them. I'll give you like a minute or two. want you to flip them around. So take this one, flip it around. So X is on the left, not the right. Good job, Sally. Good job. Make sure you're flipping them and graphing them. Good. Yeah, good. Good. Read this backwards. If I could circle this, I want you to read this. Buzz, come on. Trevor. Buzz, go get one of my pencils out of my pencil holder and use one of mine. Sure. Oh, read this backwards. You didn't flip it right. Read this backwards. You didn't flip it right. Remember, you're picking the whole thing up and flipping it around. Nikki. Hey, Brett, turn around, please. No. Put that back. I said a pencil. Buzz, no. Pencil, not my pen. Pencil. You need to flip it around. So X is on the left, Chloe. Okay, hold on. Michaela, let me see. Okay, good. Mitch, be careful. Try to be careful, okay? All right, most of you are okay. Let me clarify this one more time. Okay, and compound inequality. Okay, X is in the middle. Listen. The first thing you need to do is split them up and rewrite them. So here's the problem I saw with some of you. Flipping around this. Remember when we did this in 6.1 and 6.2? I tried to explain this to you as if I could pick this up and flip this around, that's what you're doing. Do not rewrite this sign like it is. You need to pick this whole thing up and flip it around. So what this really says is X is greater than or equal to -4. You're either reading it backwards or picturing you picking it up and flipping it around. Okay, give me a head nod. Does that make more sense to some of you? Okay, I'm going to write the word and in between it. The other one is X is less than or equal to 0. Questions for me on how to split it up before I keep going? If we need to do more of these, we will. Chloe, you okay? Sure? Not lying to me? All right, so let's graph this one. On our graph, let's put our -4 here and our 0 here. X is greater than or equal to 4. We should have a filled-in circle above -4. Greater than or equal to means to the right. X is less than or equal to 0. Filled-in circle above 0. Arrow going to the left. Connect them in the middle. And compound inequality. X has to be between -4 and 0. You okay? Okay. All right, let's go to our graph. I'm going to put our -4 here. The origin's here. We should have 2 solid vertical lines going through each of them. George, are we shading in between or on the outside? Good. We're shading in between because it's an and compound inequality. Questions on that? Okay, let's go to example 1. And let's do this first one together. So right underneath that example 1. Okay, so it gets a little bit more difficult as we go through the notes. So this says all real numbers that are greater than or equal to -3 and less than 5. Anytime you're translating a verbal expression to an inequality and you hear or read all real numbers, that means that you need a variable. So all real numbers means use an X or use some variable, okay? All real numbers that are greater than or equal to, all real numbers that are greater than or equal to -3. So we're translating greater than or equal to our inequality sign. We are writing down our -3. This is an and compound inequality because it says and right here. So write down your and compound inequality. Less than 5. So this random less than 5 over here, also relates back to, it's a compound sentence, also relates back to all real numbers. So you still need to have another x here and put your less than 5 and translate it to an inequality. Is everyone okay on how we just translated that? Okay, we're not going to graph this one. Questions on how to translate that? Okay, give me a head nod. Are you still finding this easy? Okay, let's do another one. There's a mistake on the smartboard on this one. This should be a +3, and this should be the word or. Okay, so number 2 says, all real numbers that are less than or equal to 3 or greater than 6. I want you to take a minute. I want you to translate that one on your own. Try to. All real numbers, Alec, please stop, that are less than or equal to 3 or greater than 6. So see if you can translate that one on your own. If it's an or compound inequality, you should have the word or in between it. If it's and, you should have and between it. So read carefully. Yeah. Yes, quickly though. All right, Nicolette, what'd you get? Less than or equal to? Okay. Good job. Everyone make sure you have exactly what Nicolette said. X is less than or equal to 3, or, buzz, it's an or compound inequality. I'm almost done. Please face the smartboard. Or X is greater than 6. If we graphed this, graphs would be going in opposite directions, right? And your coordinate plane would be colored on opposite sides. Questions on that? Okay, let's flip over your notes and let's go to example 4, letter D. Okay, and this might be the last one that we'll do for today. Okay, example 4, letter D. Okay, this is an and compound inequality. Section 4 of your notes are all examples of solving compound inequalities. Okay? This one in particular is an and compound inequality, and I chose this one because this is as difficult as it will get. So our objective or goal is to get the variable by itself in the middle. Okay, Alec and Buzz, quit it, okay? Just sit there. Do you need this one? Okay, so we need to ask ourselves, we need to figure out how to get rid of this -1. We want to get the variable all by itself in the middle. Anyone have any idea how we can get rid of that -1? John? Good. We're going to add 1 to the middle, to the left, and to the right. Just like solving an equation, what you do on one side, you do on the other side. On an and compound inequality, what you do in the middle, you have to do on the left and on the right. So the 1 is going to cancel here. Cross that off. Make sure you guys are all paying attention. Some of you are daydreaming. We're going to add here, -7 plus 1 is -6. Drop down the inequality sign right here. Drop down your -z. Drop down your less than. 3 plus 1 is 4. Is everyone okay with step 1? Okay, now what? Dan. Awesome. And what's going to happen, Dan? And what else is going to happen? Okay, and, sorry, there's one more thing. Awesome. Why are the signs going to flip? Good. A multiplier divide an inequality by a negative. Remember from lesson 6.1 and 6.2, the inequality signs are going to flip. So there's a lot of things going on here. This becomes +6. This is going to flip to greater than. -1 divided by -1 is just +1, so that's a z. This is going to flip to greater than. 4 divided by -1 is -4. Is everyone okay? So multiply, divide by negative, flip the inequality sign. Let's split it up now. So those of you that weren't good at that, pay attention, please. We're going to split it up because it's an and compound inequality. So we're going to read this backwards or use symmetric point, flip this whole thing around. So this really says z is less than 6. Write the z on the left, flip this around, write your 6 on the right. And z is greater than negative 4. Lauren. If there's, okay, good question. If the word or is in it, it's or. Like the next one, see how the word or is in it? This one just has an x or z, any variable in the middle, so it's and. Anyone else have questions for me? Okay, your homework's going to be different than the other classes, so pay attention, okay? 6.4, I need you to open up your homework packet too. I need you to open up your homework packet to 6.4. And I need you all to try 1 through 7. Now, I'm not sure how I feel about you guys with this, but I guess we'll see tomorrow. I will spend about 10 or 15 minutes tomorrow finishing the notes and probably graphing more with you, as well as flipping things around. Okay, 6.4 in your homework packet, and don't move if the bell rings. Our pages 38 and 39. Find it, please, before you go. And then let me just explain the first part. 1 through 7 is all you need to do. Numbers 1 through 3, you're translating verbal expressions to inequalities, just like we did on the notes today. If you need to use your notes, use your notes. 4 through 7 are solving and compound inequalities. You have one really good example in your, in your notes. So if you need to use that, Trevor, sit down. You can use that. Okay, 1 through 7, have a good night, have a good day. I'll see you tomorrow.